What is a function and why use them? Well, functions are used in order to be descriptive of the quantities you are trying to compare. For example, suppose you model the speed of a rabbit using the equation y equals x to the second power. Although we have a nice equation, the representation is a bit dry, so we can do better. To make it more appealing to the reader, you can use variables that describe the quantities you are trying to convey. Now instead of y and x, I have d for distance and t for time. So if you give me a distance, I can calculate how much time it takes for you to travel that distance. And that's the modeling of the hare's speed, or the rabbit's speed, I should say. But even though this is great, and this is very, very useful, we can actually do better than that. And that's where the function notation comes in. We can upgrade our notation and say d is a function of time. We can write d of t equal to t squared. So again, if you give me any time t, you give me 2 hours, 3 hours, 4 hours, then my function, my distance function, will give you how many meters the rabbit has traveled. And that's pretty much the function notation. So let's apply it with some examples. So here it says evaluate the function with the indicated value. F of x equals 2x plus 5, and then x equals 3. So f is the function f. That's my function. And f takes in any value, any x value. So here we're going to replace x by a 3. So everywhere we see an x, we're going to have to replace it by a 3. So here we're going to replace by 3. Let's rewrite this. We're going to write f of 3. That's going to equal 2. We're not going to write x anymore. We're going to write 3. So 2 times 3 plus 5. So just some caution here on the left. This is not f multiplied by 3. This is f of 3. F of 3. That's my left hand side. So here, let me split the equation. I have my left hand side. I have my right hand side. All I have to do is simplify this right hand side. So 2 times 3, that's 6. We still have that 5. And then 6 plus 5 is 11. So we get that f of 3 is equal to 11. Using the mathematical notation, we write it like this. Let's do one more. So here, this time our function is 6x plus 12. And we have to evaluate it at x equals negative 4. Everywhere we see an x, we're going to replace it by a negative 4. So let's write this. So we have f of negative 4. And that's going to equal 6 times x. But again, x is negative 4. So x times negative 4 plus 12. Let me split the equation. So I have to evaluate the right hand side. 6 times negative 4, that is going to be negative 24. And we're going to add 12. And then negative 24 plus 12, that's going to give me a total of negative 12. So we get that f of negative 4 is negative 12. Let's do one final example. Here, the food mart has a gumball machine. Each time a quarter is inserted, 7 candies come out of the machine. If there are 2,700 gumballs inside, how many gumballs will be left after 19 quarters have been inserted? Use the function below in order to solve this problem. Here my function is g of q equals 2,700 minus 7q. So g, that's a variable for gumball. Whoa. G is for gumballs and q is for quarters. Here g of q means that g is a function of quarters. So we're inserting quarters. And for this problem, we're inserting 19 quarters. So we want to evaluate g of 19. Rewriting the equation with 19 is this part right here. So everywhere I see a q, I'm going to replace it by 19. That's what I'm trying to figure out. So let's evaluate the right hand side here. So we have 2,700 and we're subtracting it by 7 times 19, which is 133. Now for this part, it's okay to use a calculator. I mean, 7 times 19, that one's not too easy to calculate at the top of your head. So here it's fine. I'm talking more about like 5 times 7, 7 times 3, 9 times 12. Those computations hopefully should be automatic. But anyways, here 2,700 minus 133. I'm getting a value of 2,567. So G of 19 is 2,567. What this answer means is that after 19 quarters, 2,567 gumballs will be left inside the machine. Go ahead, try the rest of the problems on this formative, and then we'll talk about graphs.